I'm going to demonstrate the force on a current carrying wire in a magnetic field. So let's take a short segment of the wire of length dl, and let's turn that into a vector by giving it a direction, and the direction will be the direction of the current flowing in that segment of the wire. So the force on that segment of length dl will be the current flowing times the cross product of dl and the magnetic flux density. Now I have this stack of magnets. I'm going to attach them to the positive terminal of this battery. Okay, and now I'm going to take this wire that I've bent, and I'm going to put this pointed end here on the negative terminal of the battery, and then the bottom part, two parts on the opposite sides of this magnet. Okay, so the current is going to flow out of the battery into the magnet and up through both ends of this wire, and then back in the negative terminal of the battery. And what we'll see is there's going to be a force perpendicular to these two sides which will cause this wire to rotate. So here's an illustration of what's happening. So here we have the battery and the magnet attached down here, and I'm showing some of the magnetic field lines coming out of the magnet and going back into the magnet. So when I attach the wire like this, we see that we have a current that's flowing up both sides here, and a magnetic field that's perpendicular to the wire, and so there's going to be a force on the wire that is at a right angle to both the flow of the current and the magnetic field, as given by this equation. So let's stand up the magnet and the battery and attach our wire.